All right, hello everybody. Good afternoon, good evening, wherever you are over in the world. I would like to introduce Kris Erickson, who is the research manager of 3D printing over at HP, and today he's going to be telling us about HP's 3D printed electronics with multi-jet fusion. So with that, I'd like to hang it over to you, Kris, and take it away.
Great. Thanks so much, Greg, for the intro. All right, so let's jump in. So 3D print electronics with multi-jet fusion is what I'm going to cover. Kris Erickson over at Palo Alto, HP Labs over in Palo Alto. So let's get into advancing slides. There we are. The base technology that we're creating the 3D print electronics approach off of is multi-jet fusion. So people may or may not know the polymer 3D print tech that HP has going on. So just a quick intro such that we have context for how we're building our 3D print electronics approach. So you start with this powder material, you're gonna spread it out, get a nice even layer over the powder bed. You're gonna put some energy down to help prep the layer. You're going to put down fusing agents and detailing agents. These aren't binders. It's more something that's going to interact with the energy afterwards, such that you can fuse, essentially melt the polymer, and then not fuse, keep it as powder everywhere where you don't want to have part. And then, of course, as you imagine, layer by layer, build that up into a three-dimensional part. So that's the base technology. And again, really quick intro. There's more info out there if people want a better primer. We have a handful of different materials that are available and a few different printers as well. So we have kind of more production ones that produce these gray, easy to turn black in color parts. You can also do other post-processing to get them to have different colorations. And then there's also a smaller printer that is able to do full color. So especially with that color one, it's interesting to think because you have these products that HP is putting out that have this process I talked about, but then where I'm at, HP Labs, we get to mess with that base process. So we get to mess with the powder, putting different ones in, mess with the agents, the energy to do different sorts of things. And why I highlighted the color in particular is that you can think about now, since we have ability to print those agents wherever we want within the print bed, within each layer as you build things up, then we can go ahead and have essentially a different color that's going to be the electronic agent. So we'll get into that in a moment, but why generally are we interested in 3D print electronics? So this is definitely a good question, and being, a overall product focused company like HP is, we have to kind of start there. And there's a lot of opportunities that, again, lots of folks are probably aware of in terms of being able to push limits in a few different interesting, exciting technology spaces. So being able to have unique RF communications, there's a lot you can do with being able to liberate where you're putting your conductive traces for RF designers, for antenna designers, being able to get higher and then overall unique functionality, more directional sort of antennas if you can tailor them in 3 dimensions. Also, in terms of active sensing and feedback and communications within parts, we have quite a few different types of parts that are printed right now with the MJF technology, and a lot of those are either going to have electronics put on afterwards by somebody else that is interested in getting a functional component in the end. And there's also a lot of applications that we're looking at that would benefit tremendously from being able to get individualized feedback during their use from things like being able to sense if it were in some sort of footwear or other application like that. So being able to both sense out and communicate out is another area that we're very interested in. And then you kind of get into this area of structural electronics. There's a bit of a industry around molded interconnected devices, and overall being able to have both the form and function going from more of the flat PCB into more of a printed circuit device that will take that final form factor that is almost always going to have more of a 3-dimensional nature as opposed to a 2-dimensional nature. So those are kind of the main areas that we're looking at and are interested in, and overall being able to do